Assalamu alaikum everyone. So today is the second part of our linked list lecture, and we will do a little recap of our previous lecture, and then we're going to move on to the next part of the linked list. Okay, so in the previous lecture we learned what a linked list is. It's a collection of data objects not connected by memory but through direction. These are the directions, and the beginning or the very first element of the linked list is called the head. The last one is called the tail, and the last one is pointing to a null point or a null. Okay, we learned what each of those structures can contain, and we'll call them node in our lecture. And we said that we learned some functions, so those functions we learned today. Okay, we learned how to create those structures. As you can see, there are three examples here. This is the most simple one. This one is including multiple variables, and this one including multiple pointers. Okay, and we also learned how to initialize the linked list, and then we learned how to print all the numbers actually traverse through the linked list. Okay, so today we're going to learn two different functions, the insert function and the delete function. Okay, so the insert function inserts something inside the linked list, as you can clearly understand, and the delete function deletes something from the linked list. Okay, so at first we'll go through the code line by line for each of those functions, and then we'll see how it actually works. Okay, we'll see a demonstration. So inserting some element inside a linked list can be done in three possible ways. One is at the middle of the list, beginning of the list, and the end of the list. Okay, let's see. So we already have a function here which I wrote. Okay, so let's see what this function does. Okay, so this function has no output, but it only has two input. Okay, one is this key value. This is the key value that I have to insert. This is the pointer of the linked list, or the pointer to the head of the linked list. We need this. Without this we cannot actually traverse through the linked list. Okay, so at first we have to create the required node, right? So at first we create a temporary structure node pointer. We will use this to traverse through the linked list just like we did in the previous print function. Okay, so at first we initialize that, and then we allocate a memory. Okay, so what does this mean? This means this is the same thing as we did earlier here. If you remember, this is to allocate a memory equivalent to the memory size of a node. Okay, so here we are actually allocating the same amount of memory to this temp. So what does it mean? That means we are allocating a node or a memory of a node to this pointer. Okay, so this pointer has two variables, so we are actually assigning values to all of these variables. Okay, so the very first thing is we are placing this key value that we have to insert to the key variable of this node. Then we are saying that the next pointer is pointing to null. So you can clearly understand that this is the node that we are going to insert into the linked list, and we are going to traverse through the linked list, and we are going to place this inside the linked list. Okay, so next we are going to traverse the linked list. So we have this temporary head node, right, or head node pointer we can call it. So this head node pointer is different inside this function, right, because the main function has a separate head pointer. So even if we use this one, we will not lose the linked list. So we can actually use this as our traversing parameter. So we'll start with this one. This one is already pointing to the very beginning of the head. So what are we doing? While my head next is not equal to null, we are actually traversing through it. How? Head is equal to head next. Okay, and then once we reach the end, only in that case the head next will equal to null, and this will break, and then we just write that head next equal to 10. Okay, so what actually happens here? Can you understand? Is it the middle of the list, beginning of the list, or the end of the list? If you see this part of the code, then maybe you'll understand that we only stop once we find the null pointer. So where is the null pointer? At the very end of the linked list, right? So what we're actually doing is adding an element to the end of the linked list. So you can do some experiments. You can do it using the beginning of the list, or you can actually insert element in the middle of the list. So when you want to insert in the middle of the list, you have to have some parameters also. Okay, so let's actually see how this works. Let's just see a demonstration. So let's say we already have a linked list. Okay, so this is my linked list. Currently it has 3 elements. So what are we doing? Previously it had a head. We haven't yet inserted. Okay, so this is before inserting any node, or sorry, actually before inserting one node. We can assume the 2 nodes have already been inserted, but we're going to see an example so that we can understand. So this is the head node, so it contains the value minus 33. Forgive my bad handwriting. And this node, let's assume that the value here is 7, and let's assume that the value here is 2. Okay, so let's say that we want to insert an element with the key value equal to 5, right? So what can we do? As we have already seen, this is actually a code of the insert node. If we increase the size, the same code that we have seen in the slide. So here we can see that at first we are creating a node pointer, and then we're allocating some memory. So let's say we are creating a node pointer, then we have allocated some memory. Then what are we doing? We are assigning key to the key variable or key member of that node. So this node will now have the key value 5, right? And then what are we doing? We are actually assigning null pointer to the next variable or next member of temp or temporary. So this one will be now pointing to null. Okay, so if you can remember, this linked list should also have some directions, right? So this one is directing to the second node, this one is directing to the third node, and this is actually a dummy node. Okay, you can call it a dummy node. Why dummy? Because we will never erase this node, we will never edit this node. This node is only there so that we can start pointing somewhere in the linked list. Okay, so this is pointing to 7, this is pointing to 2, and as this is the end of the element or end of the linked list, this is pointing to null. Right, so this is what we have. Now what are we doing? We are saying that while my head next is not equal to null, I will be traversing the node, traversing the linked list, how head equal to head next, right? So at the very beginning, where is my head? My head is passed to me as my input parameter, right? And we called the input parameter from here. So as you can see in the previous code or the previous lecture's code, we were inserting nodes by passing the head and then a number 5, right? Or any number. So what are we inserting here, or what are we passing as input parameters? The head pointer of the linked list and a key value. Okay, so this head at the very beginning should be pointing to the very beginning or starting of the linked list. Then what are we doing? We are saying head is equal to head next until head next is equal to null, right? So at the very beginning, is my head next equal to null? No, it's actually pointing to 7, right? So what will happen? Head equal to head next. So this head will now be pointing to this 7. So let's change it. So this head is now pointing to 7. Is my head next equal to null according to this condition? No, it's still not equal to null. It's pointing to 2, right? So again we'll execute this line, head equal to head next. So what will happen? Again the head pointer will be pointing to this one. Now let's check the condition. The condition was if my head next not equal to null, we'll continue, and if it is equal to null, we'll stop, right? So here now my head next is equal to null, right? So this is where we stop. We break out from the while loop, and after we break out, what happens? Head next equal to temp. So what are we doing now? we are saying that this head next supposed to be pointing to null, now it will be pointing to 5, right? So we change it. Now head next is pointing to this new node, not head next. Try to understand it. Okay, so now as this one is pointing to this one, as you can clearly understand, our linked list has been edited, and this is our new linked list. This is the first element, the dummy element, the second element, third element, and the fourth element. Okay, so this is actually how the inserting works. Okay, and that's the same thing that we're doing here. So if you have any questions regarding this, you can ask in the comment of that post in the Google Classroom. Okay, so next we are going to see how the delete node works. So actually deleting something from the linked list is very easy. Why? Because you do not actually have to move all of the nodes forward or backward. What you can do is just remove a node from the entire list and just make this one point here. Okay, so if you don't understand what I just said, don't worry, I'm going to explain it once we go through the code. Okay, so we have a code here, right, as you can see here. So let's at first see what are the cases that we can go through. So obviously, just like the previous one, we have three possible cases here: from the middle of the list, that means deleting something from the middle of the list, or deleting something from the beginning of the list, or deleting something from the end of the list. Okay, so now we are going to do something else. We are not going to actually do beginning or end. We are going to delete something from the middle of the list. So when we are deleting something from the middle of the list, we have to say, or we have to indicate what we are deleting or which node we have to delete. So what we'll do is we'll pass the head pointer, which is the beginning of our linked list, or the pointer which points to the beginning of the linked list. Then we are going to pass the key. So this key value is telling me which node I have to delete. Okay, so whenever you want to delete something from the middle of the list, you have to specify in which position or which key you want to delete. Okay, so then what are we doing? We are actually declaring another structure node pointer previous. Okay, why? Because we also need the previous pointer now, not just the next one. We will understand once we go through it. So now we are traversing the list, so we have to go to the required node where this key will match, and then we'll delete that. So at the very beginning, my head next is not equal to null, right? Because I am at the very beginning of my list. Then if my head key is equal to key, only then I will break. That means that I found the key that I want to delete. Otherwise, I will keep on continuing. So how do I continue? If my key is not found, I will assign the previous to the head value, and the head value will be assigned to the head next. Okay, so what am I doing? Each time I'm going forward, I'm keeping the current node in the previous variable and the next node in the head variable. So I'm moving forward, but I'm also keeping the previous node. Okay, so once we reach the key that we want to delete, then we are breaking. And then what are we doing? Now we have found that node. Now we have to remove that node from the list. So as you can see, now this is very easy. Why? Because we just have to assign the previous node's next pointer to the current node's next pointer, and then we'll just have to free the current node, as you can see here. Then what will happen? The previous node will be pointing to the next node, and in the middle, that node will be erased using free. So it's that much simple. So let's see an illustration. Okay, so let's assume that this is the node, this is the linked list that we want to delete from. Okay, so now we want to delete one node from it, but this time we want to delete the node 2, or the node with the value 2, which is at the middle of the linked list. Okay, so again, from the very beginning, my key value is 2, and my head is pointing to the very beginning of the linked list. Okay, so this is the code. I've already written it. I'm going to uncomment it now. So what are we doing here? We want to delete some node, and we also have the head pointer. We have the key of the node we want to delete, and the return type is void as usual. We don't have to return anything. We're just deleting something. Then we have our previous pointer. So let's create the previous pointer. We have something called, okay, so we have not yet allocated any memory, so it's just a previous pointer. Let's just write previous. We have not yet allocated any memory. Okay, so then what are we doing? We are writing that head next not equal to null. So until this is false, the loop will continue. So where is my head now? My head is pointing here, and my head next is pointing to 7. So my head next is not equal to null. Okay, so then we get inside if head key equal to the key that we want to delete, then break. So what is my head key currently? My head key is minus 333. So obviously this will never equal to the key that we want to delete, because this is something that will never come, or something that will never be inserted. We assign the value in such a way. Okay, if you remember the last lecture. Okay, so then what are we doing? We are saying that previous is equal to head and head is equal to head next. So we have written this just before this line. Why? Because if you write this line after this line, what will happen? It will actually point to the current head, but we need to store the previous head. So we are storing the previous head, then we are making the head point to the next node. So if this is my previous pointer, let's just give a star here. It's my previous pointer. So what is happening? After this line, the previous will be pointing to the head. So this will be pointing here. Okay. Then what are we doing? We are saying that the head will be equal to the head next. Okay. So now what will happen? This head will be pointing to the next node, which is 7. Okay, so now we are checking whether my head key is equal to key again. Okay, so now what is my head key? My head key is actually 7, right? So is this equal to the key that we want to delete to? No, right? So what will happen? It will again move on to the next line. So again my previous will be equal to head and my head will be equal to head next. So the previous, let's erase it. The previous will be pointing to the head, and the head is currently pointing to 7, right? So my previous will also be pointing to 7. And then what? The head should be pointing to the head next, right? So the head will now be pointing to head next, which is 2. So now currently when we are at this stage, then we will get inside, and then we have another condition, head key equal to key. So when we find this, we were supposed to break, right? So in this case, is it true? This is my head, right? And my head key is 2, and the key that we're supposed to delete is also 2, right? So this is where the loop will break, but we still have the same pointers pointing to the same places. Okay, so previous will be pointing to 7 and head will be pointing to 2. So now what are we doing? We are saying that previous next equal to head next. So what is my previous next? This is my previous, right? So my previous next means this pointer where this is pointing to. So currently my previous next is pointing to 2, and we are saying that my previous next will be equal to my head next. And which one is my head? My head is this one, and this one is pointing to 5, right? So previous next will be pointing to head next, which means 5. So that means 7 will be pointing to 5. And just when we write this, 7 will be pointing to 5, that means this pointer is no more there, right? Because we are using this pointer to point to 5. Okay, fine. So now 7 is pointing to 5, but we still have something else left, right? This 2 is still there, and this is still pointing to 5. So that's where the next line comes in. We are freeing the head, and my head is which one? This one. Okay, so now we'll be freeing the head. Freeing means we'll be erasing this memory. So now the head is clear. So as you can see, the entire linked list has changed into something else, and now it again has 3 elements. This one, 7 and 5. Is it clear? So this is how actually you can insert and delete node from the linked list, and this was the delete node. Okay, so let's run it. Okay, and let's see whether it actually works. So what are we doing here? At first we're initializing the node or initializing the linked list, then we're inserting four integers, we can call it 5, then 7, then 3, then 1, right? Then we're going to print it. So it's supposed to print something like this: minus 333 for the head key, then 5, then 7, then 3, then 1, right? Then what are we doing? We are deleting the node 3, we're deleting the node 1, we're deleting the node 5, right? So after that, what should happen? Only the variable, which one should be left? 3 gone, 1 gone, 5 gone, so only 7 should be left. So then we're again printing, and this should actually print 3, then 7. So this is what it should be printing. So let's run it and see whether it actually works or not. So as we can see, this one is the first one, and it's printing the same thing as we have written here, and this one is the second print, so it's the same here. Is it clear? So we are successfully deleting all the nodes. Okay, so this is how the delete function works. So if you have any questions regarding the delete function, you can ask again. So this is the main function that we have already seen, and we have seen what will be printed, and we have already seen what happens when one node is deleted. Okay, so this is an example where we are just deleting the variable 3, right? So can you tell me what should be printed in this case? Give a thought to it. Okay, what should be printed if 3 is deleted, okay, from this linked list after all these have been already inserted? Okay, and also think about this: what if the node to be deleted is indicated by the node position? In this case, what will happen? If this is not the node position, then what will happen? And if this is the node position, then what will happen? Okay, so that's sort of like an assignment for you. So then we have the find or edit function. Okay, so this will be another assignment for you, but let me give you a hint. What the find function will do, it will traverse the nodes to match the key value, just like we did in delete function. As you can see here, we are going through the list until we find the key value or until we find the null value. Okay, so what will happen if we don't find the key here? What will happen? Actually, this will never be false, so this will never be true, so it will never break from here, but it will reach the end, and then this while loop will break. Okay, so in that case, actually this might or might not cause some problems, right? So how can you handle that? That's also another thought for you. So what we want to do here is, we will traverse the node to match the key value, we will traverse the node to match the key position. Okay, so depending on what we have to do, if we have to edit based on the key value, then we will be traversing using the key value, and if we have to edit using the position, that means we want to change something in a specific position, then we have to traverse the nodes using the position. Okay, then we have to print the position or key value as per requirement. Let's say we want to delete a part, then we have to print that part, and again, sorry, we're editing a part, so we have to print that part before editing and after editing to see whether it's working properly or not. Okay, so the only difference between the delete function and this one is, instead of deleting that specific part, you have to replace the key value with another value. Okay, so this is actually the end of the slide. So please tell me if you have any questions, and if you do not want to ask questions publicly, then you can actually give me questions in my I don't know what that website or profile is called, Kubul or something. I have already given you my link, so what you can do is you can give it to me using that, and I guess I can give you a small hint on how to write the edit function here, and after giving that I will end the class. Okay, so if this is the linked list, what you would have to do is, you would have to let's say this would be pointing to this one. So let's say I want to change the value from 7 to 3. Okay, so what will happen? I have to traverse it. I will start from the very beginning. Then when I reach the required node, this will now be pointing to 7, right? So when we find that, we will just say that head key is equal to 3. So then, oh, the eraser is too large. So then this 7 will be replaced by 3. Simple, isn't it? Yeah, yes, you can call it simple. So that's it. So ask questions, because I am getting very few questions, which was not supposed to be the case, because even during class you asked more questions, and as my lectures are very bad, video lectures especially, so you should have more questions, but I'm not getting any questions. Okay, so if you have any questions, please ask. I'm going to end the lecture here.